Let me close some of these. All right, so this is 129S, and we're up to Chapter 3. And the videos of last week are up there, so you can view them if you want to. So let's take a look at Chapter 3. All right, so web technology. So you understand the basics of how the web works, and the fundamental protocol is HTTP. This was invented to make the internet possible. It's a connectionless protocol, which I mentioned before. One of the fundamental weaknesses of it is every request is processed once, you get a response, and then the server forgets everything about it. It doesn't retain any memory of what happened before. That's what they mean by saying it's connectionless, and that is to make it easier to write a server and easier for the server to handle a lot of traffic. So it has no state. So your request will look like this: get some page with a directory to a page, and then there are some parameters, like here's something about a family, Roboto something, and then you have a name of the host you're trying to reach, information about whether to keep the connection alive, and a bunch of header fields, which we'll talk about here. These are optional. You can skip them, but they do affect things. So this is the URL of what exact thing you want to see. The part after the question mark is the query string, including parameters. The version of HTTP is 1.1, which is the most common version in use. And then you've got the referrer, spelled wrong, by the way, but you must spell it this way, that's the standard. And that is the URL the request originated from, which in retrospect is a pretty bad idea. I think the idea was to track the effectiveness of ads, but it has two consequences. In the first place, it leaks out private information. You go to a page, and they can see what page you came from, which is not really any of their business. And the second thing is some site developers don't understand this, and they think they can trust this information. So if you come, like you log in and you go to a welcome page, then you go to like administration page, they could look and see, did they come from the welcome page? Well, that means they must have already logged in. I'll take that as proof that they're logged in. But you can just put anything you want in this referrer field. It's not protected in any way. So this is like caller ID on your telephone. Caller ID on telephone can be changed to anything you want. So trusting it is not wise. Anyway, that's an issue. The host name of the server is important because many websites share the same IP address now. And so even though you've sent a request to the right IP address, you need to also tell it which host you're trying to contact. And the cookies, down here, all this mess, a whole bunch of terms, something called a seg version, a GRV insights, _GA, AMP, MV something. These are all random values, whatever parameters you might want for your web app, and this is usually what contains the login information. There's an authentication cookie that was assigned to you when you log in, and now every time you send a request to that server, it will automatically attach all the cookies, and in those cookies is a code number it uses to remember who you are. That's how it works. This creates the bizarre situation. Instead of logging in on the server and creating a state on the server that is remembered, because the server knows you've logged in, and then will somehow know when you've logged out, what happens is it sends data to the browser, and the browser has to echo it back to the server for every request to prove they're logged in. Every single request has to individually carry an ID card to prove that you've logged in, and we're going to exploit that. That is arguably not a very great design decision, but that is how the web works. So these cookies are all important. And the browser sends a response, or the web server, I should say, sends a response to the browser. And the first thing is a status number, 200. There's a few values of this. 200 is okay. 200 means you've asked for something, and I found it, and here it is. If for some reason I could not fulfill your request, I give a different number. And so then you'll have some information about what kind of content is here. And so this is JavaScript. And here it is. Yep. And this is some of the content below down there. And, all right, and the server banner will tell it what kind of software it is. This is Apache running on CentOS. That also is not verified anywhere, and in fact it is a recommended security procedure to change your server banner to something totally generic. So it does not tell people which version of what server you're using, because that's information they don't need to know, and it could make it easier for them to hack you. And now the server can set cookies. The browser just sent up a cookie value with cookie header, but that was put there by the server when the server had a set cookie value. So when you end up correct username and password, it will log you in, and then it will issue the set cookie header to put the cookie in your browser, which it remembers and then sends back with future requests. All right, Pragma tells it not to store the response in its cache. Otherwise, browsers do cache responses, keeping a local copy, so if you load a page, and the page, for example, uses an image you've seen before, it does not bother to ask the server for it. It looks in the browser cache. I don't know if this is important anymore. This was a big deal back in the days of dial-up internet, when the internet was really slow. Then it would make the page load quite a bit faster. But anyway, your server can control, it can ask the browser not to cache it, but it has no way to verify that the browser in fact doesn't cache it. All right. And they have an expiration date here. You can put an expiration date on the content. So I tell it when it expires. If you go back to this page, after that date, automatically load the whole page from the server because it's considered to have expired and you should refresh it. Otherwise, you often get a copy from your cache. And this was happening to students last week. They were going to one of my pages and they were clicking to enter flags, and they were getting an old enter flags page because they needed to manually refresh the page because my server apparently isn't sending good enough expired tags. Anyway, that's the response. The message body after the header, this blank line, this is the message body, and that will contain data of the type up here in content type. So this is JavaScript. So GET is the most common method. GET just asks to see something on the server. You can send parameters. If you make a bookmark of a GET request, it will record the parameters. So let me point this out. This is important to know. If you go to Google and you search for, say, duck, then you see up here, google.com, search Q equals duck, and then a whole bunch of other stuff, all in the URL string. This is a very bad place to put secrets because if you save a bookmark in the browser, it will save that whole thing. And if you look at the server log, it will save that whole thing. So if you have a password up here, it's not handled very securely. Now, it's probably encrypted going to the server with HTTPS, but it's not at rest. It might be visible to a lot of people. So it's not considered a good practice to put anything sensitive in those query parameters. All right. All right. And what you should do if you want to send sensitive data is use the post method instead of the get method because it moves the parameters down into the body where they are not put in browser favorites or stored in logs. That's the better plan. So a post is what you typically use to perform an action like logging in or buying something. And therefore, if you go back in your browser, you'll get a warning saying, wait, if you want to show that page again, I'm going to have to repeat a post request. And that might mean you buy another copy of this book or whatever you were doing. Refreshing a get is harmless, but repeating a post means you actually take some action twice, which is more dangerous. There are other methods. They're very rarely used. Head just gives you the header, no body. You just get server information. Options shows what verbs are allowed, what options are allowed, with like get and post. Put lets you put data on the server, and that's used somewhat by like cell phone apps, but I don't see it used much by web apps. So this is the Uniform Resource Locator. Here's the structure. You have a protocol, then a : / then a host name, and you can have an optional port number here. If you don't specify it, it will be the default port number for that protocol, and then you have a path to a file. Now, in the early days, this was a literal structure of the website. So an old-fashioned website using old techniques like mine, this is actually true. If you go to 129S, there is a folder on my server called 129S, and there's a file in there called 129S f25.shtml. That is the old-fashioned Web 1 system. You have a literal map of the structure of the server in the URL. Modern pages, like if I go to, say, Amazon, I can get this thing to, right. If I go to Amazon and I click on something, then this shows some compression stocks, women, DB. These things are probably not really folders. They're using other techniques where they look like a folder, but they're probably treated as parameters and run by scripts on the server and connect to databases. And this whole page is not, there's no page ending in HTML sitting on a server. This page is dynamically constructed from all kinds of different sources and different servers working together. Every person that goes here will see different ads, probably different products, different prices. So it's a thing to know, and we're going to see a lot more of this. These things that look like folders and file names might be something entirely different. In the early web, they were literally folders and file names, but you can write a script to interpret them any way you want, and people do. Anyway, all All right, so the port 80 for HTTP, which is almost never used anymore. Almost everything is HTTPS 443, which is encrypted. And there's also RESTful, that's what I was just saying. RESTful URLs put parameters in the URL, not the query string. So instead of having make equals Ford and model equals Pinto for a car, they might have search Ford Pinto, where search is a action, and these are actually parameters. They put them where they look like part of the folder. I don't know why people do this, but they do. And so it means you can't make assumptions about what these things mean. They mean different things for different kinds of web servers. So let's take a look at a Kahoot. Oh, I see some questions here. Anthropic can still train the data for 30 days. Well, I need 5 years. Well, it's a good question, and I don't know. And someone had it on here. It might be a legal reason or something. All right, well, I don't have any light to throw on that. So let me take a look at the Kahoots, which should be here, 129S. And this is chapter 3A. So hopefully they'll be in some kind of order, and they are. Okay, 3A. There we go. I'll wait a couple more measures, see if more people are coming. 15 students and 11 in there. That's pretty good. I guess that's all we're getting. Okay, so what part is often get? That's called the verb or the method. It's get or post, usually. Tells it what to do with the resource you're pointing to. It's not the query string. The query string is what comes after the URL, after a question mark, like the thing you're searching for on a search page. That's a parameter, which is used by a script after you've reached the right file on the server. All right, what method requires user confirmation when clicking back? Post. Okay, remember that. Post is the one that takes action, and you probably don't want to casually repeat it. All right, what parameters are stored in bookmarks? Yeah, the query string, as I was saying. It's in the bookmarks, therefore you shouldn't be putting secrets in the query string. All right, and which of these is RESTful? this one here is RESTful. By the way, this has happened a lot at colleges. They'll have a structure like this where it's just your student ID right there, and a student will just try changing the ID and they'll see the grades and stuff of the other students. This is called insecure direct object access. It's a very common flaw on the web where resources that should be private are just available to everybody, but they think you won't find them unless you've logged in. This is a very common mistake. And so, and by the way, many of the students that told their administration about that would get expelled and prosecuted and stuff, which, like I say, white hatting is not recommended. Many telling people about security problems, if they're not ready to hear you, they'll usually just blame you. Anyway, all right, so let's see who won. All right. Jason, they're going to tell me who they are if they want their points. Jeffrey, that looks like a real name. And that person, 27, yeah, okay, these people have to tell me who they are if they want their points. All right, anyway, all right, so let's go back to here. So the headers, there are a whole bunch of headers up there. So connection tells it whether it should keep the TCP connection alive or not. If you don't close it, you can send up to 100 requests to an Apache server before making another connection. That's a handy fact when you try brute forcing into servers. Content encoding tells you what kind of encoding is used for the body. Commonly you allow gzip, which means the content is zipped, and if you look at the raw response, you won't be able to read it. Your browser unzips it. Content length is the length of the body in bytes. Content type tells you what kind of data it is. Transfer encoding talks about some various ways it can be encoded, sending the data. These are all general headers. Then request headers, accept tells the server what kind of content you're willing to accept. Accept encoding tells you whether you're allowed to be zipped. Authorization can send credentials. The cookie is more often where you put credentials, but you can also have an authorization tag for it. The host specifies the domain name you're trying to reach, since there can be multiple websites hosted on the same server. If modified since tells you don't bother reloading the page unless it has been modified since the previous date. You could send it, how old is my current copy? Do I need a fresh copy or not? If none match would check something here to determine whether the browser can use its cached copy. And origin is used in AJAX. AJAX is asynchronous JavaScript and XML. It's a way to make dynamic pages like Google Maps. Google Maps, you can drag them, and it just reloads part of the page, not the whole page. And that's done with AJAX. It's a whole bunch of little queries going up to the server, loading little bits of the page at a time, and the origin tag is used as part of the scripting there. And referrer, like I say, specifies the URL you came from and is spelled incorrectly. And user agent tells it what kind of browser you're using, which in these days, the main purpose of this, there are two purposes. The first one is to tell if you're using a cell phone, because then I probably want to show you a smaller version of the page. And the other thing is to tell if you are a bot crawling the internet for information, like the Google bot crawls to load the Google engine. And now the big problem is all the AI companies crawl the web like crazy. And they say now you will get something like 12,000 requests from an AI bot before you get one valid customer. So the web, everybody that publishes content on the web and makes money from it is very upset about AI, because the AI crawls your page like crazy, using up all the bandwidth, and then they give an AI summary to the customer, so the customer never goes to your page, so you never get to show them ads or make money off them. So they say if we don't start blocking all the AI bots, which Cloudflare will now do for free, then the internet will die. Nobody will put up any paid content because there'll be no way to monetize it. We'll see how this goes. What's that?
Which vendor did you say that blocks them for free?
Cloudflare. Yeah, Cloudflare protects your server in many ways, and they've just implemented the feature to block the AI crawlers, which is, and a few companies have made money, like Reddit sold the privilege of crawling their data to, I think, OpenAI. And that's what people want to do. They want you, the AI companies, to pay you for caking your data, but right now it's in the early days. The same thing's true of actors. The actors guilds are very nervous because you can make an AI copy of an actor and not pay the actor anymore, and therefore they're afraid that they're going to get no more money and no more jobs. Although something just recently happened. The Rock, the famous black muscle actor, he appeared in a movie and they had AI scenes. They had AI version of him and they paid for it and put it in the movie, and then they found out there was a decision made a few months ago by one of the courts that an AI generated product cannot be copyrighted because it was not made by any human. And they took all those scenes out of the movie because they wouldn't be able to enforce copyright on them, and that bothered them. So in a way, that may help. Anyway, that's the problem with AI stuff. The legal consequences of AI are still being determined. And so response headers have a bunch of response headers here. Expires tells the browser how long to cache it, and server gives you information about the server. The main one we talked about is set cookie. That's pretty important. The others are not used that often, or they're not essential to understand at this point. Anyway, cookies are really important. Once your browser stores a cookie, every time you go back to the same server, it will repeat all the cookies. So after you do something with a set cookie, it will then repeat the cookie. So you can set the expiration date, you can set the domain for which the cookie is valid, and this is what's a major security measure of the web, is the same origin policy. If you have a Yahoo cookie, it will only send the Yahoo cookie to the Yahoo website. It will not send it to somebody else, because if somebody else could steal your cookie, they could then log in as you. They would be accepted as having logged in as you. And so stealing a cookie is one of the common hacking techniques. So set cookie header can also determine the path for which it's valid. It can mark secure, which means it'll only transmit the cookie over HTTPS, never HTTP. And you can set it to HTTP only, which means you can only load it over HTTP, which if it secures there would be HTTPS. You cannot load it from JavaScript. And we are going to use cross-site scripting to steal cookies, and the HTTP only flag would prevent that. So here's the status codes. 200 means the request is successful. 400 means there's an error in the request. 500 means there's an error on the server. 300 means you're redirected to another location, and 100 is informational. I don't think I've ever seen a 100 response, but you see 300 and 400 and 500 a lot. Especially when you're hacking into a server, 500 often means your request worked. The server was unable to process your request, which often means your attack worked. Anyway, so 200 is the most common. 300 and 302 means the site has moved somewhere. The 304, 400, 401, and the famous 404 are what happens when you can't find what you're looking for. And 500, internal server error, some kind of error on the script. So people have had a lot of fun making, memes and stuff about these codes. All right, so HTTPS is secure HTTP. We talked about it before. It does not stop all kinds of attacks. It's not 100% secure, but what it does is provide authentication of the server so you know who you're talking to, and encryption so nobody else can read the traffic. That's the idea. And now it is TLS. In the early days it was SSL, but all versions of SSL are obsolete and insecure, and now we're all using TLS, which is just the later protocol to replace the earlier SSL. Now, most people use proxy servers now. Cloudflare is a proxy server. My site is behind Cloudflare, so when you load my pages, you are not loading them from my server, you're loading them from Cloudflare. And Cloudflare fetches the data from my server, so I don't have any direct traffic to my server. That protects me from a lot of attacks. It also means my website will load faster, and it can handle more traffic. I can have just a single weak server, and Cloudflare makes copies of it all over the world that people can load it from. So that's called a reverse proxy, when it's behind a server. When you put it behind when your client goes out through a proxy, that's a forward proxy, where your local machine does not load web resources directly. It loads into the proxy, and then you look at the copy. A lot of companies do this so they can filter the web. If they want to stop you from going to porn sites and games at work, then they often use a proxy server. You have to go to the proxy server, and the proxy server has a list of URLs that are acceptable and unacceptable. You're not allowed to directly contact the web. You can only see the stuff that your company permits you to see. It's commonly done. So you can have HTTPS. HTTPS protects you from man-in-the-middle attacks. If somebody in the middle of there's a lot of people in the middle of your traffic. When you go to the local router, you go through the local network, you go to your company's proxy server, you hop through a dozen machines on the web, all those people are in the middle of your transmission. So there are a lot of people that in principle could inspect and modify your data on the way out. And that's why HTTPS prevents this, because you get a key and encrypt the data with that key, and only the person at the other end can decrypt it. So all the intermediaries can't decrypt it to inspect it or modify it. That's the idea. This means that the company cannot filter your traffic, but they want to filter your traffic. They want to inspect your traffic to see if you're sending offensive stuff, which would get the company in trouble, or company secrets leaving the network. They want to investigate what's coming down to see if you're downloading malware or illegal content. So companies do want to intercept the traffic, and what they do, there are two techniques. The one thing they can do is a man in the middle with a fake certificate, So you go to like google.com, your company will intercept it and have a company.com certificate, and therefore they'll have to add it to your browser. So your official company laptop or company machine will have an extra certificate telling it to trust your company's server. And if you bring a machine from home, it won't trust the server. You'll get error messages when you try to use the web. The alternative is to buy a real root certificate, which are not supposed to be available, but it's an open secret for a decade or more that you can get them if you're powerful enough. Then you impersonate the person at the other end. That violates the whole security model of the web, but it's been happening for years. Law enforcement agencies and large companies are able to bribe their certificate authorities to impersonate their certificates, which means you don't really know who you're talking to. You're talking to the real Google, or you're talking to somebody who paid a bribe for the privilege of imitating Google. Anyway, and there's a lot of people get mad about that, but that's the way it is. All right, so you send a request to the proxy. If the proxy allows it, it returns a 200 status and then lets you get through to the server. All right, there's authentication. There used to be something called basic authentication. It still exists. It just takes your username and passwords and encodes it with base64, which is not encryption. By the way, it's okay if you transport it over HTTPS. That puts a layer of real encryption on it, but without that, it's not very safe. And there are other things like NTMM and Digest that are generally used inside Microsoft local networks, not usually on the web. They just send another kind of signature to prove who you are. And they're all pretty weak cryptographically, so you should have HTTPS connections to put a layer of cryptography you can trust on top of them. And by the way, if you get a VPN, then that adds another layer of encryption on top of the HTTPS, which might make you a little safer, although realistically, you're secure enough using HTTPS in the first place. Anyway, so let's take a look at another Kahoot, which is here. There's a bold move, no name at all. All right. All right, so which request header tells the server what web page you're coming from? That's the referrer, all right? All right, where can a server specify that the cookie must always be sent with encryption? It's in the set cookie header. You specify the secure flag. All right, what status code indicates that the page was not found? 404, very famous. All right. All right, what protocol does HTTPS use? TLS is the one that's now used. These are all encrypted protocols, but HTTPS now uses TLS, Transport Layer Security. All right. I know who that is. Don't think I know who Oscar is. I think I know who All right, I think we can go through another section here for the break. So, server-side functionality. If you have a simple website like mine, it just has pages and you look at the pages. There's hardly any scripts, there's no login, any of that stuff. But for dynamic content, you have more complicated things like you're going to log in, post data, purchase products and such. So now you have to have scripts on the server, and they're going to get parameters from the web forms and process them. So you can send the parameters in the query string, in the file path, and the RESTful type URLs where they look like folder names, in cookies, or in the body of the request. In principle, anywhere in the request you could put information that's used by the scripts. It could use the user agent, and so on. Any part of the request could be used by a script on the server, however you want to use it. And so the script on the server will be in PHP or VBScript or Perl or any of a dozen other languages. ASP, Java, the web servers are things like Apache and IIS. You have databases usually connected to store lists of products, lists of customers and passwords and other things, and a lot of other back-end components. SOAP-oriented web services that take simple object access protocol just to fetch data of any kind, and directory services. And like I say, a modern website includes something like 10 or more servers all running different services in different languages communicating to patch together what you see. And so very often there are misunderstandings as the data goes from one server to another that lead to security vulnerabilities. So Java is what large-scale enterprise applications tend to use. It scales out to really large fleets of servers to handle a large amount of traffic. That's the idea. It's more difficult to write them. You get paid more as a Java developer. It's easier to write things in like PHP for Apache, but that only works for small sites like mine. For big sites, you need to have Java to handle complicated arrays of servers. So they use this stuff, Enterprise Java Bean, plain old Java objects, and Java servlets. These are part of the components of a Java web server. And there's something called a Java Web Container, Apache Tomcat being the one I see most commonly. I've used it a few times, but it's pretty complicated, and I never really understood it very well. All right, and so you can have third-party components along in there too. Log4j became notorious about 8 years ago. Log4j had a very serious command injection vulnerability, the type we'll be using later, which caused all the federal agencies to come to a screeching halt and find out which of their servers are using Log4j and patch it right away. It was one of the most serious vulnerabilities in the last 10 years. So ASP is Microsoft's application framework, and it's a competitor to Java. It uses Microsoft's .NET framework, and Java compiles things to bytecode that's run in a Java virtual machine. .NET compiles things down to what they call intermediate language, and you run it in what's called a .NET runtime. And if you take the malware analysis or exploit development classes here, which we offer next semester, we go into these things. The malware analysis, I think, is the one we really go into this one. And you learn how to hack .NET applications. In the mobile device hacking class that's being taught this semester, you learn how to hack Java applications, which is what Android applications are. They're both very easy to hack because the so-called compiled code is very close to source code. So you basically have the entire source code of every app, which makes it very easy to find the important information in the app. Anyway, Visual Studio is Microsoft's development environment for all kinds of applications, including ASP.NET. It's very popular. I find a lot of people who use this won't use anything else. They just want everything to be in Visual Studio. They've even added Visual Studio plugins to do things like coding PHP for Linux on it, because the Microsoft-oriented people are afraid of Linux and never use it. They want to stay in a Microsoft environment, even writing Linux code. So you can even put a COBOL plugin in Visual Studio. People put everything in Visual Studio once you love it. It's the all-purpose platform for Microsoft-oriented developers. PHP is the open source language intended to run on Linux servers. This is what I do because I'm mainly a Linux server guy, not really a Windows server guy. I use Windows only as a target. And so this is LAMP servers, Linux, Apache, MySQL, and PHP. And that's the free kind of server used by small businesses. Large businesses typically use the Microsoft stuff because they have to integrate with all their other Microsoft services. All right, PHP is notoriously unsafe. One of the most common problems with PHP is local file inclusion. It often has file names and parameters, and you can often modify the path to refer to unexpected files. That's the fatal flaw of it. PHP frequently has that kind of security vulnerability. My page got hacked once through a PHP script on it by a student. Nobody really nasty has ever hacked me. Just my students have, and they all get extra credit. All right. Anyway, there's a bunch of products here. PHP Boulevard, PHP Nuke, which is used by the Department of Defense for their unclassified stuff, which I was in a bug bounty program for. PHP MyAdmin is a administration console that a lot of people use for bulletin boards and small websites. I've never used it, but it's commonly vulnerable because people tend to use weak passwords on that page. Then there's webmail, photo galleries, shopping carts, wikis, all available in PHP. All the open source community has donated many PHP scripts to do everything, and that's where your smaller businesses will be running it. Ruby on Rails was all over the place about 10 years ago. Everybody was writing in Ruby on Rails. I haven't heard that much of it lately. It seems to have fallen in popularity. SQL is still with us, though. Almost every database runs with SQL. It stores data, retrieves data, and when the next project, I think we'll probably do it next week, you'll practice hacking into SQL databases. It's an essential skill for any pen tester. Data is stored in SQL all over the world, and it has a series of really common vulnerabilities that you learn how to exploit. SQL injection vulnerabilities. XML is a way to format data on the web where you make it look like HTML. So you might have a pet named Ginger, so you have a pet and slash pet, and then you have pets, and in the pets you have a dog container and a cat container. So you have these angle braces, you have opening tags and closing tags for each of these. This is considered a standard way to structure data, and in 2008 Microsoft switched to using XML for all of their Office documents, which was a giant leap forward for them. Before, they had a proprietary binary format for Word and Excel and PowerPoint that made it very hard to search through old data on the server and respond to lawsuits. So they switched to just a plain text format for all their files, a plain XML, which is much more standard and easy to interoperate with other products. SOAP, I mentioned before, SOAP just sends requests to the server that look like an HTTP request and send some kind of data to the server or retrieve some kind of data from the server. All right. You get a response. So you send a request here with a post, and then you get a response, which is a 200 OK, and you're sending some data back and forth here. Just another way to format data and move it over the network. So if your user-supplied data is included, it can have code injection vulnerabilities. And we'll play with that in the project. You'll see XML injection is another way to do it. If you can inject a less than and greater than sign, you can fool the server into misunderstanding your request. Same as you can do it with SQL injection or command injection in other languages. So let's take a look at another Kahoot, and then we'll take a little break. 3C is here. All right. see the number is visible. I guess you can change your avatar's appearance. Somebody's flipping through all the faces there. All right. All right, so what systems uses these POJOs? Plain old Java objects, that's part of Java. All right, what language is used on LAMP servers? PHP. That's what most of my stuff is written in. All right. All right, what system looks like that? That's XML. Looks like HTML. You have these opening and closing tags. Ooh, that's missing a slash. A defect in my question. Anyway, all right. All right, what system uses WSDL? I'm going to have to flip back. I don't remember which one it is myself. I think it's SOAP, yeah. Web Service Description Language is part of the SOAP protocol, I think. I'll go back and look at that slide after I record the winners, which is Jeffrey again, good. And Kutrani again. So let's go back and look for that. That would be SOAP here. Yeah, server publishes the available services using Web Services Description Language. It's part of SOAP. Okay, I'm going to stop this video and